Hey guys, welcome back to my channel, The Math Pat. And today we're going to do prime factors, highest common factor, and lowest common multiple for the Edexcel course. So we're going to start with some easy questions to build on the basics, and then we can move on to more advanced questions. So question number one says, write 525 as the product of its prime factors. So first thing first, you need to first understand what a prime number or a prime factor is. A prime number is a number which is divisible by itself or 1. So examples of prime numbers are 2, 3, 5, 7, 7, 11, 30, and so on. These are your prime numbers. Numbers divisible by themselves or 1. So to build on that, we have a term which is called prime factors. Now, prime factors is basically the only difference is that now we're restricting it to factors. Factors are numbers which, when you multiply, you get another number. So we're going to be talking about prime factors and how what's it called? A multiple can be broken down into its prime factors. So 525. Now, as you can see, the last digit is 5, which means this number is divisible by 5. So what we will do is we'll break down 525 into its prime factors. So if we divide 525 by 5, that basically gives us 105. So which means if you split it, it's going to be 105 times 5. Now this is a tree diagram which you make in order to break down the number into its prime factors. 5 is a prime number, so that means we cannot further break it down because it's only divisible by itself and 1. So we let 5 be as it is, and we start breaking down 105. Now 105 once again is divisible by 5. So it's going to be 5 times 21. So once again we leave the 5 as it is and focus on breaking down the 21. 21 is 7 times 3. Now both 7 and 3 are prime numbers. So that means we cannot further break these numbers down into their prime factors. So now if we write 525 as a product of its prime factors, it's going to be 3 times 5 times 5 times 7. That is it. All you have to do is basically break down the number into its prime factors. You can start from any number. There's no restriction as to you have to choose a specific factor to begin with. You can start with big numbers. You can start with small numbers. It's up to you. Then if we move on to the next question, it says, express 56 as a product of its prime factors. Pretty much the same thing. So what we're going to do is we're going to break 56 down. We know that 56 is basically 7 times 8. 7 is a prime number, so we leave it as it is. 8 is 4 times 2, and 4 is 2 times 2. So as you can see, we've broken down 56 into its prime factors, which are 2 times 2 times 2 and times 7. So basic thing. Just a 2-3 mark question, you have to do these steps and you'll have your answer. Now let's move on to something different. Question 4. Trams leave Piccadilly to Eccles every 9 minutes and Didsbury every 12 minutes. A tram to Eccles and a tram to Didsbury both leave Piccadilly at 9 a.m. at what time will a tram to Eccles and a tram to Didsbury next leave Piccadilly at the same time? So in these questions, what they're basically asking us is to find the lowest common multiple of 9 and 12. So what we're going to do is we're going to start writing the multiples of 9. Multiples of 9 are 9, 18, 27, 36, 45, 54, and so on. So let's stop at this for now. Now we write down the multiples of 12. Now for 12, we're going to have 12, 24, 36. Let's stop at 36. Why? Because like they're asking for the lowest common multiple. So since we've already figured out that the lowest common multiple over here is going to be 36, so there's no point in, spending more time in writing the rest of the multiples. Stop over here, save your time, and you have your answer. So what we're going to 12 is your 36 is your lowest common multiple. So at what time will tram to Eccles and tram to Didsbury next leave Piccadilly at the same time? It's going to be every 36 minutes. So that means we're going to do 9 plus 36. 9 hours plus 36 basically, which is going to be 9:36 a.m. Then move on to the next one. Now it's saying write 600 as a product of powers of its prime factors. So if you go back to the previous one, they were just asking us to write it as a product of its prime factors. But now it's the product of powers of its prime factors. So the answer, like the method is still the same, but like the way in which you write your final answer, that's going to be slightly different. So we're going to begin with 600 and break it down. Now 600 is 30 times 20. Let's start with 30 is 5 times 6. 20 is 5 times 4. Once again, you can pick any factor. There's no restriction. You start with big numbers or small numbers, whatever you're comfortable with. 5 is a prime number, so we leave it as it is. 6 becomes 3 times 2. And 4 becomes 2 times 2. Now, if we rewrite 600, it's going to be 5 times 3 times 2 times 2 times 2. And another 5. Now, what we're going to do is we're going to regroup the similar factors and write them as the product of powers of the prime factors, which means 5 times 5 becomes 5 square. Actually, wait for the thing on this. Yeah. 2 times 2 times 2, so 2 cubed times 3 times 5 squared. Always start with smaller number and I go in the ascending order. Then if we move on to the next question. Question 6 says that an integer a equals to 2 to the power of n times 3 times 5 to the power of m. And they're asking us to write 8a as a product of powers of prime factors. Now the difference between a and 8a is that a is being multiplied by 8. So 8a would be 8 times 2 to the power of n times 3 times 5 to the power of m. Now we know 8 is not a prime number. So let's break 8 down. 8 is 4 times 2 and 4 is 2 times 2, which means 8 can be rewritten as 2 times 2 times 2, which is 2q. So what we're going to do is we're going to replace the 8 with 2q. Everything else remains as it is so far. And now since we have two similar bases of the number 2, which means what we can do is we can combine it as a single base. And if you remember from the rules of indices, if two similar bases are being multiplied, what we do is we add the powers. So it becomes 2 to the power of 3 plus n, and 3 times 5 to the power of m remains as it is. So this is your answer for the product of powers of its prime factors for the term 8a. Then question 7 is same. Okay, 7b says find the smallest whole number that 720 can be multiplied to give a square number. So for that, let's do 7a first because they're linked basically. So 720 gets split into 72 times 10. Now 72 is 8 times 9. 10 is 5 times 2. 5 into a prime number, so you don't need to further break it down. For 8, we know it's 4 times 2. For 9, it's 3 times 3. And 4 becomes 2 times 2. So now that we're done with the tree diagram for 720, we know that 720 is equal to, we have 2 to the power of 4, 3 square, and 5. Yeah. So this is what the product of its prime factors looks like. But where they want just a product, so we're going to write it as 2 times 2 times 2, 2 times 3 times 3 and times 5. Yeah. Sorry, they didn't want the power, so we write it as product factors. So now that we have the answer to 7a, let's move on to 7b. What I'm going to do is I'm just going to keep this part and then we're going to need this part. So now that we have the factors, okay, this is a tricky question. Like most people think that it's like very difficult to solve, but it's actually pretty simple. It says find the smallest whole number that can be multiplied to 720 to give a square number. So what is the condition of a square number? The condition is that the power has to be 2 or like an even number basically. So if we combine these and write these as the product of powers of prime factors, we know that this is 2q, this is 3 squared, and this is 5. Now if you look at the powers of these factors, 3 is already squared, so it is a square number. But 2 is raised to the power of 3, and 5 is raised to the power of 1. So what we need to do is we need to change their powers. So in order to do that, what I would do is I would multiply 2q with another 2 and 5 with another 5. So when we do that, what happens now is the result looks like 2 to the power of 4 times 3 to the power of 2 times 5 to the power of 2. As you can see, all the powers are even now. Hence, the smallest whole number, which we need to multiply to 720 to make a square number, is 10. That is your answer. If they were asking for the biggest whole number, that's like, can be anything, because obviously you can just keep on multiplying, like increase the power, and it can be like any even number. So for the smallest, you just multiply it by like 1 digit. Yeah, in most cases 1 digit, and you just raise it to the even number, and that's what you have. Then question 8 says write 3.6 times 10 to the power of 3 as a product of powers of prime factors. So what we're going to do is first going to convert 3.6 times 10 to the power of 3 into 3600. Now 3600 will break down into 36 times 100, 9 times 4, 3 times 3, and 2 times 2. For 100, we can do 4 times 25, 2, 2, 5 times 5. As you can see, 3.6 times 10 to the power of 3 can be rewritten as we have 1, 2, 3, 4, 4 2s, so 2 to the power of 4 times 3 square times 5 square. I would like to do something different. Okay. Find the highest common factor of 140 and 245. So for this, what you need to do is you just start listing down the factors. So for 140, you know that the factors are 14, 1, 72, 27, and 14, 10, and 5 is also a factor. So 5 and 28. Yeah. And for 245, now this is going to be divisible by 5. So 245 divided by 5 is going to be 5 and 49. Then I'm going to do 245 and 1. Then 245 is divisible by 7. So 7 and 35. For 140, we also have 35 and 4. And 245 is, I think, only divisible by 8. Yeah. Now, if you look at the factors, we can see that the highest common ones are we have a 7, we have a 5, and 35. So for this, what we do is 140, we draw the tree diagram for 140 and we draw the tree diagram for 245. So what I'm going to do is 140 is 14 times 10, which is 2, 7, 10 is 5 times 2. For 245, we're going to do 245 is divisible by 35. Yeah, 35. I'm going to do 35, 7, maybe 7 times 5. So now if we write on the factors as a product, 140 is going to be 2 squared times 7 times 5. Whereas for 245, we have 5 times 7 squared. So as we can see, the common ones are 5, 5, and 7. So HCF would be 5 times 7, which is 35. It's basically like factorization. Factorization, we take the highest common factor from, right? So we're applying the same rule here. The highest common numbers common are 5 and just 7. Then, okay, lowest common multiple. So we have to circle the lowest common multiple of 5, 15, and 25. So we know that 5 is only the multiple for 5, so that is out of the option. 45 is only a multiple of 5. 5 times 9 is 45. And for 15, it's 15 times 3. So not for 25. So once again, that's also out of option. Now 75 and 150. 75 is a multiple of 5 because 5 times 15 is 75. And 25 times 25 times 3. Yeah, 5 times 3 is also 75. So all three have 75 in the times table. For 150, we know 15 times 10. We know 5 times 30. And 25 is going to be 50 divided by 5, 6. So 5 times. So both these are multiples, but it says lowest common multiple, which means 75 is the answer, not 150. Then moving on, this thing. Okay, question 18 is different. So for question 18, it says you're given that this number equals to 3 to the power of 11, and we have to write this number as a product of its prime factors. So we already know that this part is equal to 3 to the power of 11. So if we rewrite this is going to be 3 to the power of 11 times we have 6 zeros, so that means 10 to the power of 6. That is it, literally. The only difference was that they added zeros at the end. So you just count the number of zeros and raise 10 to the power of whatever the number of zeros are. And you're done. Then, okay. And this question says, Carla runs every 3 days. She swims every Thursday. On Thursday, 9 November, Carla both runs and swims. What will be the next date on which she both runs and swims? So if she swims every Thursday, that means like after every 7 days she's swimming. So we have to find the lowest common multiples of 3 and 7. Okay, so 3 multiples of 7. So for 3, we have 3, 6, 12, 14, 18, 21, 24, 27, and so on. For 7, we have 7, 14, 21. To stop at 21. Why? Because we can see that that is the lowest common multiple. That means if on Thursday 9th November both she swims and runs, so when is she going to both swim and run like on the next day? So that means 9th November plus 20 days. So if we add 21 to 9th November, now what is the date going to be this day? So we do I think it's only 30th. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 15, 16, 17, 30th November. Yeah. So that is the next date at which you will both run it. If you have any questions or comments about any of these, let me know in the comments below and I'll help you out.